Chapter 3, Lesson 4 of Geometry, looking at parallel lines and the triangle angle sum theorem. And in this video, we're going to classify triangles. We looked at triangles last time and the triangle angle sum theorem, which said that all the angles add up to 180 degrees. And in this video, we want to look at how do we classify triangles. In other words, they all have different sizes, different shapes, different angle measurements, and we can classify these by looking either at the sides or by looking at the angles. So we're going to look at both ways here, and we're going to do classifying by a side. So when you're asked to classify a triangle, we're going to look at the lengths of the sides. The lengths of the sides determine the classification, and these are the three vocabulary words that you'll need to know. The first one is equilateral. Now, that's kind of a big word, but if you break it down, it kind of tells us what we're looking at. We're looking at equa, sounds like equal, so we're looking at equal. And then lateral is another word for side or sideways. So we're looking at equal sides. So an equilateral triangle, all the sides in the triangles are congruent. They're all the exact same length. So your typical equilateral triangle is up here, and all of the sides would be the same. Now you would have to be told this by putting tick marks on there, or there's a theorem later on that we'll talk about that we can determine by the measure of the angles, but that's kind of a sneak peek into something else. The second type of triangle is an isosceles, and we'll do a lot of work with isosceles. And this is where you have at least two sides congruent. And notice it says at least two sides. So it doesn't say exactly two sides congruent. So you can have another name for an equilateral would be an isosceles, because this has at least two sides that are equal. It just happens to have three. The more specific name is equilateral because all three sides are equal, but it also has the same properties or characteristics of an isosceles because it has two sides, or at least two sides are congruent. So isosceles, please note the spelling, isosceles. So you can get the spelling correct. Isosceles has at least two sides congruent. The third triangle is what we call a scalene triangle, and this is when none of the sides are the same length. So scalene, none of the sides are the same length. Really not much more to say to that. It's just kind of a weird word, scalene. I'm not exactly quite sure what the origin is. Maybe that would be something you'd look up and see how does scalene and no sides being congruent come into play. I'm not sure what the relationship is. So equilateral, all sides equal. Isosceles, two sides equal. And scalene, no sides equal. So that's how you would classify a triangle, just by looking at the lengths of its sides. Now the other way to classify a triangle is by looking at the measure of the angles. And in this case we have four types of angles that we'll look at, or four types of triangles, and they're tied very closely to some angle measurements that we looked at earlier this year. So let's take a look at the first one, and again it's kind of a big word, but equiangular, again the two words equa sounds like equal. Angular sounds like angle, so equal angles. So in this case, all of the angles are the exact same measure. And actually, that looks like an equilateral triangle as well, because all of the angles have exactly the same measure. Now, if you knew that, how could you figure out the measure of each angle? Well, if you apply the triangle sum theorem, we know that all of them add up to 180, and if they're all the same, we would simply divide it by 180, so each angle in an equiangular triangle is equal to 60. And there's a theorem, like I said, there's a theorem later on that we'll talk more about that and that property. The next one is an acute triangle, and this is where all of the angles in the triangle are acute angles. And you remember, acute angles are angles that are less than 90. So any angle that's less than 90 degrees, if all of the angles are less than 90, this would be considered an acute triangle. Here's another example up here. Each one of these angles is less than 90, so that would be acute. A right triangle is where you have exactly one right angle. Okay, now a right angle is 90 degrees. So is it possible to have a triangle with two right angles? Well, if you think about it, if the triangle angle sum theorem says that all three angles add up to 180, if two of the angles are 90, that's 180 total, what's the third angle going to be? Well, it can't be 0, so actually there's no way to have more than one right angle in a triangle. So a right triangle has exactly one right angle. And we're going to do a lot of work with right triangles later this year when we start studying a little bit of trigonometry, because that applies to right triangles. The last type of angle is called the obtuse triangle, and again it has to do with an obtuse angle, which we looked at earlier this year. And an obtuse angle is more than more than 90 degrees. So an obtuse triangle is a triangle where it has one angle that's more than 90. Now, can it have more than one angle more than 90? In other words, could it have two angles more than 90? Well, if you think about that, if you had two angles that were, let's say, 100 each, that's 200. Well, what do all the angles in a triangle add up to? They only add up to 180, so there's no way to have more than one obtuse triangle in there, because they would add up or exceed the 180 degrees that they all add up to. So let me show you a few examples here and types of problems you'll have to be looking at. So classify the triangle by its sides and its angles. So this would be what kind of triangle if we were looking at just the sides. Well, these are kind of like tick marks. All the sides are the same. So this would be equilateral. And if we were classifying it by its angles, all of the angles are the exact same measure, so it would be considered equiangular. Now, this also could be considered an acute triangle because all of the triangles are less than 90 degrees, but the more specific name would be equiangular, and we always want to go for the more specific name as we're doing this. Okay, this would be what kind of triangle? An acute, all of the angles are less than 90, so this would be acute triangle. An acute triangle. Okay, I'm going to slide the rest of these very quickly. If you want to stop the video, then you can. Now this one looks like it's acute. We don't have any measurements, so we're going to have to go by appearance, but all the angles look to be less than 90, so that would be an acute triangle. Oh, let's go back to that. What about the number of sides? What would this be by its sides? Well, all of the sides appear to be different lengths, so this would be scalene. Now you might make an argument that these two look the same, so it might be isosceles, but I think that's probably scalene. Okay, we don't have any angle measurements, so it looks like this is an obtuse angle though, so this would be an obtuse triangle if we're classifying by its angles. And by its sides, it doesn't look like any of these are the same length, so that would be scalene. Again, this angle appears to be more than 90, so that would be an obtuse triangle, and the sides are not the same length, so this would be scalene. And your acute obtuse triangles are always scalene. Here you have a right angle, so this would be a right triangle, and we're told here by these tick marks that these two sides are the same length, so that would be an isosceles. We have at least two equal sides. This looks like a right angle here, so probably a right triangle, and the sides don't appear to be the same length, so this is going to be scalene. Okay, so you get the idea. It's important to understand or know these vocabulary words and be able to apply them, and in the manner that we just did would be about the way you're going to have to do it on a quiz or a test. So that will wrap this up. We'll see you in class.